Hello friends, in this video we will try to understand the basic idea behind JPEG 2000 and why it is necessary to develop an JPEG 2000 model. So the first thing behind the JPEG 2000 is this is an image compression standard and coding technique. So again, for the image compression, the technique which we can use after JPEG is JPEG 2000. As we all know that there are few drawbacks of JPEG, and to overcome that drawbacks, it is developed by the JPEG group itself in the 2000, hence the name is JPEG 2000. So it is created by JPEG Joint Photographic Expert Group in 2000. This is an wavelet-based compression method. JPEG was the DCT-based compression method and this is an wavelet-based compression method. JPEG 2000 is wavelet-based compression method. It will give us the compression ratio such as 1 to 200. So huge amount of compression ratio that will provide to us, and hence the JPEG 2000 is very much useful as compared to JPEG. So how that will work, that we have to understand. So first of all, if I want to tell you the difference between JPEG and JPEG 2000 with the help of any picture, then I will try to show you like this. This is nothing but the output coming from JPEG, and similarly this is nothing but the output coming from JPEG 2000. So the highly efficient output you can achieve with the help of JPEG 2000, and actually whatever we try to see, this is very light as compared to this. So the highly efficient output we can achieve only with the help of this particular method or technique. The aim of JPEG 2000 is improving the compression performance over JPEG. It features such as scalability and editability. These both terms are related with each other. Scalability means JPEG 2000 is able to change the scale or able to adapt the change in the scale. Means what? Change in the bits of the given data value, or it is useful for the edit purpose also. So this is nothing but what? Improving the scalability as well as editability. It is very low and very high compression rates are supported in JPEG 2000. As we have already seen, JPEG compression ratio can support from 1 to 200 compression ratio factor. But for the very low as well as for the very high compression rates also, JPEG 2000 is able to support them. The ability of design to handle a very large range of the effective bit rate is one of the strengths of JPEG 2000, and this is an important parameter which will tell us the advantages of JPEG. What are that? The ability to design a handle to very large range of effective bit rate. The term effective will play an important role. Why? Because we already seen one of the advantage of JPEG is nothing but scalability. That means it will adapt the change in the scale of the number of bits. So here also we try to tell that thing, that effective bit rate, change in the bit rate that can be get handled while doing the compression, and still it will try to provide what? Improvement in the compression performance, or the best compression that will try to provide, and this is the strength of the JPEG 2000. Last one, it supports both lossy and lossless compression. So we know JPEG, the standard JPEG will give us the lossy compression, and JPEG 2000 is able to support both the lossy and lossless compression. So what it means by lossy compression? In the transmission, actual data is going to loss, and lossless means in the compression you are getting the compression in terms of the size of the data, but the actual data will not get lost. So this is the operation of JPEG 2000. What is that? Input, output. In between that, we have to perform the coding and decoding along with the JPEG 2000. So the first is forward transform, second is quantization, third one is entropy encoding, then compressed image. These are the steps for the encoding purpose. After that, again the same compressed image data, they will take entropy encoding. Instead of quantization, inverse quantization will perform. Instead of forward transform, inverse transform will perform to achieve the output. That means to achieve the original input back. So this is nothing but the method for operation of JPEG 2000. Now what will be the summary of these all methods that we have to understand? So the theory behind that block diagram is, first, decompose a given image into components into rectangular tiles. So we have to decompose. In the JPEG, we try to split the image. Instead of using that particular splitting algorithm, here we will try to use algorithm known as the decomposition, and which will give us the output in the form of tiles. Then apply wavelet transform on each tile. Again we have to do the same process. Like a JPEG, we there try to do the splitting of a given image into a block, and on a block we try to apply the DCT. Instead of that, here we try to decompose an image into the tiles, and on each and every tile we try to apply the wavelet transform. So there is fixed formula for the wavelet transform, with the help of which we have to calculate the coefficient of wavelet transform. After quantization, collect subbands of coefficients and describe them in their frequency range. So here you are getting some values and we have to treat them as a wavelet coefficient. Why? Because wavelet transform we try to apply it on every tile. So that coefficient we have to describe in their respective frequency range. After that, the given input or image is a part of an image known as a tile is sent to the set of wavelet filters. So the next part of our operation is nothing but the wavelet filtering, which transform the pixel information into wavelet coefficient. So we all know that once the image is going to develop, that means indirectly pixels are going to form. So that pixel information we have to convert into wavelet coefficient with the help of wavelet transformation. In the next step, they are grouped into the several subbands. Each subband contains the wavelet coefficient that describe a specific horizontal and vertical spatial frequency range of an entire original image. Spatial frequency range means individual. So every tile having some individual output, like every pixel having some individual value. So like that every value we have to assign to a vertical and horizontal lines with a frequency range to develop a original image. This means that lower frequency, less detailed information contained in the first transform level, while more detailed, higher frequency information contained in the higher transform level. So obviously, an image having the multiple pixels. For example, if an image is of 400 into 800 pixel image, indirectly 400 width, 800 height, this is the size of the image, then how much pixels will be there? 400 into 800. So like this, there will be number of wavelet coefficients. Indirectly there will be the number of tiles will be present in the image, and we have to perform wavelet transform on them. So there will be some lower coefficient or some lower frequency, less detailed information content tile will be there, and some higher frequency, high information content tile will be there. So we have to insert them into the first and the second transform level, known as the lower transform level and higher transform level. After that, the equally sized code blocks, which are very essential for the bit stream of the data, are generated within each subband. So here the word each subband will play an important role. Why? Because individual subband will try to the bit streaming of the data. This breakdown is necessary for coefficient modeling and coding, and is done on code block by code block basis. Why it is done by or done on code block by code block basis? The answer is this. Why? Because equally sized code blocks, which are essential to streams of the data, are generated within each subband. So every code block, code by code, will try to generate this breakdown for the development of the coefficient for their modeling and coding purpose. The code blocks can then group according to their significance. On the decoding side, it is then possible to extract the information according to the significance. Because of this individual code by code basis coding and modeling technique, it is very easy at the decoding side to capture the original image. That means to capture or to develop the original image by code, allowing the most significant information to be seen first. So on the image, on the developed image after the decoding, the focused part of the image, that means the high level information contents level, that will transform or that will decode first, and that image we will see first. So that part of the image indirectly we will try to see. JPEG 2000 can contain a user-defined number of layers which are defined by PCRC and context modeling. These are the methods actually which we have to see in detail, PCRC and context modeling, which we can use for development of the JPEG 2000. As we have already discussed that there are two types of layer, highly informed layer and lower informed layer. So like that, user can define or user can introduce the number of layers in the JPEG 2000. Once again, this is the advantage of JPEG 2000. Each layer stands for a particular compression rate, where the compression rate is achieved from the quantization, rate distortion and context modeling process. So exactly what it means, we can arises the number of layers because it is user defined, and every layer will having its own compression rate. The meaning or the word of the compression rate is always play an important role to affect on efficiency. Why? Because if the compression rate is good, then the efficiency will also good. So what it mean by compression rate or compression ratio? That means simply the ratio of uncompressed data to compressed data. So suppose 10 MB file you have to transfer, and after the compression you will achieve to create it as a 2 MB file, then the compression ratio will be 5:1. So like that, every layer will gives you the different compression rate, the different compression ratio, and it can be achieved using quantization, as we have already seen, rate distortion and context modeling process. So this is the basic thing with the help of which JPEG 2000 is able to produce are able to support the low compression ratio and high compression ratio also. Why? Because that will provide us advantages to contain a user defined number of layers which we can specify with the help of TCRC and context modeling. So if I want to elaborate the summary of advantages of JPEG 2000, then I can write the first one is it supports lossy and lossless compression. Why lossy? Because it uses the term quantization, and we all know that quantization means rounding up a figure. So there may be the chance to lose some data, but it supports both the type of the compression. This is the advantage of JPEG 2000. Second is this is an progressive transmission by pixel accuracy and resolution. So what it means by resolution? So resolution means your image, how it is able to gives you the detailing of the image values. Every image is developed with the help of some pixels value, and in the background or the basic theory behind the camera that will actually do such kind of work, a light line and a dark line. So that will gives you the resolution, highly resolved image we always require. That means what? For example, for a photographic lens we required 10 lines per millimeter. Indirectly there will be 5 light lines and 5 dark lines which are compulsory, non-overlapping. Though they are very close to each other, they should be non-overlapping, and alternative 5 light lines and 5 dark lines are nothing but the 10 lines per mm. This is the theory, basic theory behind the photographic lens. So we said that photographic lens will give us the highly resolved photos or highly resolution property contains to them. So this is again the progressive transmission by pixel accuracy and resolution. Indirectly JPEG 2000 will provide you the high resolution. It handles the region of interest coding. It is able to do the random code stream access. Means what? Scalability and editability. Transparency, the side channel spatial information. Now what it means by transparency or what it means by spatial information, I already told you. So its meaning is nothing but individual. So individual pixel, individual tile, individual layer contains its own information in terms of the different parameters. So what it means by transparency, it is nothing but how you are able to achieve after the decompression, how you are able to achieve the original image. If your original image is exactly equals to your input image, then the output is possess, or the block diagram or that particular method will possess the high transparency. But we all know due to the lossy compression it may not possible ideally. So there is some difference between the original image after decompression, whatever image you are getting, that image and the input image. So that there is some less transparency with the help of each and every method. But if you are going to compare the JPEG 2000 with other methods, then it is highly transparent. It contains robustness to beat error. So robustness means it will provide distortion to error. So error will get opposed by the JPEG 2000. So these are nothing but what? Advantages of JPEG 2000. Now where we can use this JPEG 2000? The first one is digital still image for HD satellite images. Second is CCTV security for the motion detection. And third one is office automation in scanner. So these are the different applications where you can use the JPEG 2000. Now in every application, if you are going to observe, then you required the CCTV security. Means especially for the security purpose, for the military purpose, the image compression play an important role, and hence they have given an application CCTV security. Means what? Closed circuit TV security by using or in the motion detection. So here we can use the JPEG 2000 like that. There are much more applications where we can use it. Still, there is some drawback of JPEG 2000. And what is that drawback? It is not able to read the JPEG file. Means, suppose the input to JPEG 2000 is JPEG file. And it will provide some output. So this is any image, no need to worry about it, but this is now image of this JPEG 2000. Now achieving after compression, you are getting such kind of output. After decompression, you are again getting some output, but it is not possible to achieve the JPEG image after decompression with the help of JPEG 2000. It is not able to read the JPEG file, and all of the images today are in JPEG. What is the main drawback of JPEG 2000? It is not able to read the JPEG file. After the decompression, even it is not able to provide you the JPEG file. Means reading off or getting back the JPEG file back is not possible in the JPEG 2000. And nowadays we all know that to store the image in different type of the format, we are going to achieve or we are going to use .jpeg format. And hence images today are in JPEG, and which is not possible to compress, to do any operation on to decompress, means to get back that image with the help of JPEG 2000. This is the main and single drawback of JPEG 2000. So in this video, we try to understand the basic block construction, advantages, applications and drawbacks of JPEG 2000. Thank you so much for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda.